Hi friends, welcome to Yuvaguru Maths Theory Lectures. We have theory and practical, two separate types of video lectures. In theory, we cover the concepts, and in practical, we cover the examples. Both this theory and practical together are useful for CBSE, ICSE, various state boards across India and outside India as well. Anyone who wants to understand maths better needs to download this Yuvaguru Maths Olympiad app. Let's focus on today's topic. Today's topic is squares and square roots. We had earlier done a similar topic called as cubes and cube roots. So these two are almost similar. What is a square? If you multiply a same number twice, that's called as square. And what is a square root? If you divide it, if you bring the factors of any numbers and if the factors are same only two times, then it's a square root. Like 9. 9 equals to 3 into 3. So 2 times 3. So that is a 3 is the square root of 9. Okay. Now the topic is not that simple. Okay. Let's because it goes deep. So square of a number. If a natural number m can be expressed as n square, n raised to 2, it should be raised to over here. Then m is the square root of square root or perfect square. Means what? M can be expressed as n square. So m is a square and n is a square root. Right? 81 equals to 9 into 9. Right? So 81 is a perfect square of 9. Hence 9 is the square root of 81. Okay, move on. Quite simple one. Properties of square roots. Below is the table. See this. Squares of a number. 1, 2, 3, 4 numbers and these squares. Okay. If we see the above results carefully, we can conclude that the numbers ending with 0, 1, 4, 5, 6 or 9 at units place are perfect squares. See this, all these numbers. Okay. None of these ending with, see here, is anyone ending with 2, 3, 7 or 8 over here? No. So the numbers ending with 2, 3, 7 or 8 are not perfect squares. So quite simple, 122, 457, 183, 928 are not perfect squares. Next, ones digit in a square of a number. The ones digit in a square of a number can be determined if ones digit of the number is known. Means what? If you know that any number is ending with 1, then definitely the square of that number will end with 1 only. Okay, that's the meaning. Or a square of any number is ending with 1, then definitely you can say that the square root may be ending with 1. See here, now the things are different. If it's number and then square it, then it's sure. But if it's a square and then we find a square root, it can be 9 also. Okay. Second point, the number of zeros at the end of perfect square is always even and double. Means 1600, 900, only two zeros, or it can be 4 zeros also. 16 0000. Okay, then also it's a perfect square, but even and double, that's important. See this, 700 square, so 49 4 times 0, so even and double. Okay. The square of an even number is always an even number, and square of an odd number is always an odd number. 6 square is 36, 7 square is 49. So odd is odd, even is even. Now important pattern, interesting pattern of a square root. See this, you just before reading this, I'll just give you the gist, what it means actually. This text is quite confusing. Important part is, see this, if you take any two consecutive numbers and make the perfect squares, then how many numbers would lie between those two numbers, those two squares? Means, see this, 3 and 4, 3 square is 9 and 4 square is 16. So how many numbers lie between these? 7. So how to find the 7? See this, add these two numbers, 3 plus 4, 7. So 7 numbers. If you take 2 and 3, for example, 2 square is 4 and 3 square is 9. So how many numbers lie between them? 2 plus 3, 5. So 5, 6, 7, 8 and 9. Right? So that way it is. Means n and n plus 1. Those many numbers lie between the perfect squares of any two consecutive natural numbers. See one more important point over here. 1 perfect square 1. Now go on adding the odd numbers. 1 plus 3 perfect square of 2. 1 plus 3 plus 5 perfect square of 3. 1 plus 3 plus 5 plus 7 perfect square of 4. Right? You go on and on and on. You'll get the next consecutive perfect squares. So we can conclude that the sum of first or natural numbers n square, or we can say if a number is a square number, it has to be sum of successive odd numbers. This is very important. If a number is a perfect square, then it has to be the sum of successive odd numbers, right? See this, 25 is a perfect square, it has to be the sum of successive odd numbers. Even if you take any perfect square, let's say 625, that is a perfect square of 25. So 1 plus 3 plus 5 plus 7 plus 9 plus blah 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 blah, all the odd numbers will be getting added. So it is surely the addition of consecutive odd numbers only. This is very important. No even numbers are to be added, consecutive even numbers. Okay. So how to know how many numbers are to be added? See this, quite simple. 5 square 25. 25 minus 1 is what? 25 minus 1 24. Yeah, sorry, that logic won't apply. 25 minus 1 24. No. Okay. Let's move on. See this, example 36. Successively subtract 1, 3, 5, 7 and go on and on and on from 36. 36 minus 1 35. 35 minus 3 32, and you should get 0. If you get 0, only then it's a perfect square. Now take the example of 35 over here instead of 36. Is it a perfect square? Let's see. 35 minus 1 34, then minus 3 31, minus 5 26, minus 7 19, then minus 9 10. Now 10 minus 11, can you do it? No. So 10 remains, it's not 0. That's why 35 is not a perfect square. So this logic you can apply when you go for a computer program algorithm. You can use this logic to find if any number is a perfect square. Now shortcut method for squaring of any number. A plus b the whole square, a square plus b square plus 2ab. This is minus instead of question mark. A minus b the whole square, a square plus b square minus 2ab. Okay. The logic behind using this formula is to convert the square of unknown number into the square of known number. So 53 is unknown number, difficult. But known numbers are 50 plus 3. So use a plus b the whole square. So it becomes 50 square plus 3 square plus this 2503. 2 into 50 into 3. Similar logic, a minus b the whole square 99, 100 minus 1. So a square plus b square minus 2ab, right? So over here it was you add this, you will get 2809. Similarly over here 100 square plus 1 square minus 2 into 100 into 1 200. So 9801. Okay. So this is a simpler way. A plus b the whole square, a minus b the whole square. We have covered many problems in practical videos. Here we are just covering the theory and giving you the concept. Now square roots. Finding the square root is inverse of squaring. Means 9 into 9 is 81. So 9 square is 81. But if you have to find the square root of 81, then it is 9. Okay. So in other words, p equals to q square. Q is called the square root of p. So what is a square root? A square root of a number is a number which when multiplied with itself gives a number as a product. Means a square root is a number which when multiplied with itself. See, when this 9 is multiplied with itself, it will give you the number answer as a product. The square root of a number is denoted by this sign, square root. Okay. Square root can be positive or negative. Means minus 9 square is also 81 and plus 9 square is also 81. Okay. Important properties of square root. Square root of a even perfect square is even, and that of odd perfect square is odd. Means 36 square root is 6 and 25 square root is 5. Odd is odd, even is even. Since there is no number whose square is negative, the square root of a negative number is not defined. Means it does not exist. Means you can't find the square root of minus 25. Okay. If a number ends with odd number of zeros, then it cannot have a square root. Means you can't find the square root of say 350. Okay, odd number of zeros. You can't find the square root of say 35,000. Yeah, but there may be a square root. Of course there is not, but 35 and 4 zeros, there may be a square root. It's not there. So odd number of zeros, definitely no square root, right? If the units digit of a number is 2, 3, 7 or 8, then the square root of the number is not possible. 2, 3, 7, 8, no square root possible. If m is not a perfect square, then there is no integer n that the square root of m is n. all this M in business quite difficult to understand. See here, M is not a perfect square, means what? Let's say 7. Is 7 a perfect square? No. So there can't be any number which is a square root of this 7. Okay, that's a simple sentence, right? 9 is a perfect square, so there can be a number 3 or minus 3 which is the square root of this 9, right? So simple sentences, only confused in the books. So finding the square root through repeated subtraction. Okay, now this we had done for squares, right? 1 plus 3 plus 5 plus 7 plus 9 equals to 5 square, that is 25. Similarly for this 36, right? Just now we had seen this. So sum of first odd n numbers, n odd numbers equals to n square, means what? 1 plus 3 plus 5 plus 7 plus 9 means how many are there? 5 numbers. So if you add them, you will get a square of 5, right? Now 6, add 6 consecutive odd numbers, you will get a square of 6. Now this pattern can be used to find a square root also. Then is used to find the square root of the given number. Obtain the given perfect square whose square root is to be calculated, means first get the number 36, subtract from it consecutively. We have just done this consecutively till we get 0. Okay, count the number of times the subtraction is performed and the performed to arrive at 0. Let the number be n. Then root of a equals to n. See this example, just now we had done it. 36 minus 1, then minus 3. How many times have you done this? 1, 2, 3, 4, 5 and 6 up to 0. Okay, so 6 times. So 6 is the square root of 36. Now let's say 25. How many times will you do it? 25 minus 1 minus 3. To come up to 0, you will do it 5 times. So 5 is the square root of 25. So that is the meaning of all these history, not required. Okay. Another method of finding the square root. This is easier. In order to find the square root of a perfect square by prime factorization. Prime factorization means what? What are prime factors? Prime factors means these are those numbers, see these ones, which cannot be divided further. 400 means you go on dividing 2, then 2, 2, 2, 2, all these. After that, make the groups of 2. So 2, 2. Okay, one group. So bring 1, 2 out of this group. So 2, then 2, 2 again. Bring 1, 2 out of this group. 5, 5. Bring 1, 2, 1, 5 out of this group. So what is there? 5, 2 and 2. Right? So it becomes 5 to the 10 to the 4, to the 20. So 20 is the square root of 400. That way this is the best method and the easiest method. Finding the square root by division method. When the numbers are large, even method of finding the square root of prime factorization slightly becomes difficult. Means if there are huge big numbers, then division method is very easy. We have solved many examples using division method in our practical videos. Let's say take one example, 784. So 784, if you go on dividing this 2, 2, 2, 2 and this, it becomes huge. Okay. So place a bar over every pair of digits starting from the digit at ones place. Okay. Means place means from here. Okay. If the number of digits is odd, then the leftmost single digit 2 will have a bar, means 34 1 bar, and 7 is single, so put 0 in front of 7 and then it becomes 07. Find the largest number whose square is less than or equal to the extreme left, means less than 7, so 2 square, right? So take this number as a divisor and a quotient with the number under the extreme left bar, means 2, 2, 4, 3 remains 384 over here. Okay. Now add this quotient, bring down the number under the next bar, means bring this 2 down, so it becomes 4. To the right means see this 84 is brought down, now it becomes 384, right? This 84 over here and bring this 2 over here. See, it might have done over here. Yeah. So double the divisor means 2 plus 2, bring this, that's why, and enter it with a blank on its right. So 2 plus 2, it becomes 4. Okay. Now give the largest possible digit to fill the blank, which also becomes the new digit of the quotient, means 4 over here and 384 is over here. So take some number over here which when multiplied by the same number means 48 into 8 should be 384. Such number 47 into 7 should be 384. Is it that? No. So 48 into 8. So a new digit in the quotient, such that when the new divisor is multiplied by the new quotient, the product is less than or equal to the dividend. Means 48, simple, remember this, 48 into 8 should be 384. So answer is 0. In case 47 into 7 is 329, it is less than 384, but we want 384. So 48 into 8, 384. That's why we choose 8. So 28 is the new digit. So 28 is the square root of 784. That way division method is used. But remember this, just theory and speaking and taking one example won't suffice. Go through the practical videos. There are many examples, tougher ones as simple ones, solved using this division method, factorization method, both these methods. Okay. So that was a theory on squares and square roots. Download Yuvaguru Maths Olympiad app from Play Store to get these videos, tests, question banks with explanations directly on your mobile. These video lectures contain theory and practical, two separate types of video lectures. In theory we cover the concepts and in practical we cover the examples. Both this theory and practical together are useful for CBSE, ICSE, various state boards across India and outside India as well. Anyone who wants to understand English maths better needs to download this Yuvaguru Maths Olympiad app. Follow us on Facebook on this link. WhatsApp us on this number for any query related to purchases. Keep studying, keep watching. Thanks.